Hi folks, we're going to be talking today a little bit about the Venus transit that occurred on the 5th and 6th of June as seen from the Solar Dynamics Observatory, or SDO. Now after the transit occurred, some conspiracy theorists, including Zeta Talk seen here, claimed that the path of the transit was wrong, that these images that were generated prior to the transit showed it taking this steep arc through the Sun, this steep line, and in fact what was seen was a much more horizontal path, not what was predicted. Uh-oh, is something wrong with Venus's position? Well, let's see. First of all, it's important to note that this little dashed line here should not go ignored. This represents the Sun's equator, and most views of the Sun as seen from solar observatories like SDO orient their images automatically so that the Sun's equator is level in the image. So if you look at a video from SDO of the Sun, notice how it moves. Notice how the prominences, the flares, everything on the Sun moves in the video. It's a nice horizontal rotation, as if the equator is oriented perfectly level in the image, and it is. It's specifically rotated to view it that way. And the reason, of course, is that's the most sensible way of looking at the Sun as it rotates. Now, a lot of these pre-prediction images, like this one here, were generated based on the assumption that you were viewing it from, say, a polar line perspective. So you had your telescope polar aligned with the Earth's axis of rotation, but not the Sun's. Most people don't have solar observatories in orbit. They're not rotating their telescopes to be level with the Sun's equator. They're putting their telescopes on their mounts to be parallel with the Earth's rotation, to avoid field rotation and to track any celestial object's motion across the sky. Now, there are multiple ways you can set up your telescope and mount it that I won't get into, and some have pros and cons. But for solar observing, if you're really dedicated, you orient your view so that the Sun's equator is level, not the ecliptic, not the celestial equator. So how do we know that this is really the Sun's equator? How do you know that I'm not just pulling this out of my rear? Well, turns out I've been tracking SDO since May, and you can see here a little video, a time lapse of 40 minutes of footage showing SDO. It's this little tiny dot right here, and I tracked it for 40 minutes this night. I tracked it on multiple nights, and based on those observations, calculated its orbit. Well, how did I do that? I simply took multiple frames out of each video, astrometrically solved it based on the star's positions, so you can put that into some software I've got, and it will give you the exact coordinates of every point in the image. And you just get the coordinates of the satellite across multiple points in time. You know when those images were taken, and you know exactly where the satellite was. And using that, we can actually calculate the orbit, which is exactly what I did. So that generates a two-line element set. This particular two-line element set is exactly what I generated. It's unique to me. It's not the official two-line elements. It's my calculation based on my own observations. That's why I didn't even bother putting in the right NORAD number here. It's just 1, 2, 3, 4, 5, just random junk. I just needed filler for that space because the two-line element set is specific to the number's position along each line. It tells programs and software exactly what each number means. And the epoch of the observations are also unique to me. The epoch in this case was generated for a point in time after the transit, and then I went back and used ORSA to rewind things. So I started tracking it, as I say, in May, and calculated the orbit. And using ORSA, we can use that orbital determination to go back to any given point in time and figure out exactly what was seen from SDO's position. So basically I did exactly that and went back in time here. Here you see June 6th, 2012. We'll rewind it here some and go back to June 5th. So this is what you would see from SDO's position, assuming that you viewed it level with the ecliptic, not level with the Sun's equator. So if you positioned SDO in such a way that the ecliptic was level, this is what you would see. Venus going across the Sun like that. Well, what does that look like? Well, if we go back here, that looks like exactly what was predicted, this steep path. But that's not what SDO actually saw, right? if we look at images from SDO, you can see here somebody has taken SDO's images of the Venus transit across multiple points in time and stacked them together so that you can see where Venus was across the entire time it made the transit. It doesn't look like what we just saw here, right? If you look, it's a much steeper path versus what was actually seen was a little more level. Well, again, that's because SDO is viewing things so that the sun's equator is level, not the ecliptic. If we go back here to the video one more time, I'll show you again. This is what you see on any given day on SDO. Everything rotates horizontally because the sun's equator is the reference point for SDO images. So if we take these images from ORSA, you can see here ORSA generates the poles of the sun. It shows you where the north and south pole of the sun are so that you know what the orientation is, and you can fix it yourself, which is exactly what I did. So I took the images, I took frames at every half-hour point of the Venus transit as predicted by ORSA, or actually, well, I guess you could call it a prediction, but it's based on the observations that I actually made of SDO's position in space. And then I derotated it so that the axis of the sun is vertical. So then the equator would be horizontal. And if we overlay that image I just showed you, what do we see? Oh, it's a match. It's exactly what was predicted and what was seen. Venus is exactly where it's supposed to be. The path it took is exactly the one it was supposed to take. The only confusion point is what the actual orientation of the images are, which in this case, they're rotated so that the sun's equator is level and the sun's poles are straight up and down. Makes sense, right? Well, nobody over at Zeta Talk accounted for that, so they thought something was wrong. And there's probably others out there too who said the same thing. In fact, I'm pretty sure I saw some, but Zeta Talk is one of the more prominent ones. So there you have it. There was nothing actually wrong. It's just a matter of image orientation. And when you view SDO and you calculate its orbit, and you view what it should have seen, assuming Venus is where it should be in its orbit, that's exactly what it should have seen. So anyway, that's all for now. Have a nice day.